Okay, today we're going to look at how to divide radicals. We've simplified, we've added and subtracted, we've multiplied, and now we're going to divide. Now the thing about dividing radicals, you're also going to hear it called as rationalizing the denominator, because if you think about it, can you have a denominator that's an irrational number? No. Remember, in order for a fraction to be a rational number, which it is, it has to be written as a fraction or a decimal. And if you have something like this, 1 over the square root of 3, square root of 3 is irrational, and you can't have an irrational denominator. So this is what we're going to look at today. How do I fix that so that it is not an irrational number anymore? So let's talk about something. Let me erase this. Do you guys remember what happens? We were kind of talking about with multiplying radicals. If I have the radical of 4 and I multiplied it by the radical of 4, what the clue to that was? This was actually the radical of 16, which means it's 4. So if you multiply a common radical, the radical by itself, it makes it perfect, and it ends up being the same number that's underneath the radical sign. For example, the radical of 6 times the radical of 6 would be the radical of 36, or square root of 36, which is 6. If we have the radical of 11 times the radical of 11, that would end up being the square root of 121, which is 11. So if you think about it, the way to get rid of a radical sign is to multiply it by itself, and it'll turn into a perfect number, which means you can take the square root of it. So if I go back to what we were looking at, that 1 over the square root of 3, and I want to turn that into a rationalized number, which means I need to turn it into a fraction, this is what you're going to do. In order to get rid of the square root of 3, I'm going to multiply by the square root of 3, which is going to give me the square root of 9, which is going to equal 3. Now, because this is a fraction, whatever you do to the bottom, you have to do to the top. So if you multiply the bottom by the radical of 3, you've got to multiply the numerator by the radical of 3. So 1 times the radical of 3 would be the radical of 3. The radical of 3 is not perfect, so let's just leave it. So your final answer would be the radical of 3 over 3. And see, that's okay because the denominator is an integer, which means it's rational. So let's look at another one. What if I have 2 over the radical of, let's say, 12? Okay. All right, so if we want to get rid of the radical of 12, we just need to multiply it by itself, which gives me the radical of 12, which in my head is going to be the square root of 144, which is going to be 12. But whatever I do to the bottom, just like making an equivalent fraction, you've got to do to the top. So I would multiply by the square root of 12. 2 times the square root of 12 would be 2 times the square root of 12, which I'm going to bring over here. Now, here's the thing. If your radical can be simplified, meaning you can pull a square root out of it, you need to simplify it. And if you look at 12, you can tell that you can pull out a perfect square. So this is where we go back to simplifying radicals. So if I take the radical of 12 and I break it down, and let's go ahead and bring the 2 out in front of it because it's there, this is going to be 4 and 3. So I would have 2 times the radical of 3 times 4. Remember doing this? And then the square root of 4 is 2. So I'm going to end up with 4 times the radical of 3. You have to simplify the numerator if it can be simplified. So now I have 4 times the radical of 3 over 12. Now, ding, 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 something should be looking at you or giving you a hint or screaming at you, whatever you want to call it. This number out in front of the radical sign is a coefficient, which is now fair game with simplifying with the denominator. So if you look at this, this is actually 4 over 12. How can you simplify 4 over 12? Well, 4 goes into 4 one time, and 4 goes into 12 3 times. So my final answer would be the square root of 3 over 3. You have to simplify it. If you leave it like 4 times the square root of 3 over 12, I'm going to take points off, and on an SAT or the EOC, it's not going to be left like that. It's going to be simplified to lowest forms. Okay, so let's look at another one. Beginning to think I might... Sorry, I keep bumping this. Let's look at 6 times the radical of 5. All right, so what would I multiply the numerator and the denominator by? The radical of 5. So this will be the square root of 5, a radical. Remember, square root, radical are the same thing. So I'm going to end up with 5 I'm going to skip that. We know that square root of 5 times the square root of 5 is 25. The square root of 25 is 5. Here, let me just do that just in case for those of you for this one. So this would be 5. So then I would have 6 times the radical of 5 would be 6 times the radical of 5. Now, is 5 perfect? Can you pull anything out of perfect? No. So it would be 6 times the radical of 5. And then the last thing you need to look at is, can I simplify 6 over 5? Nope. So I'm done. So 6 times the radical of 5 over 5. All right, let's look at number 2. I'm going to multiply the numerator and the denominator by the square root of 8, which, again, this step right here, you can skip on the bottom. You can just go ahead and jump over here that it's 8. But then I'm going to have 12 times the radical of 8. All right, ding, 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 ding. What should be going off on your head? 8 is a perfect square. So I'm going to come down here and I'm going to simplify 12 over the square root of 8. I'm sorry, it's not a perfect square, but you can pull a perfect square out of it. So this is going to be 4 and 2. That's perfect. That's prime. Bring the 12 out front. You have your 2 times your 4. Now the square root of 4 is 2. So you're going to be left with 2 underneath the radical sign, and 12 times 2 is 24. So I'm going to 24 times the radical of 2. Now look, coefficients fair game. This actually divides out. What is 24 divided by 8? 3. So you end up with 3 times the radical of 2. Again, that will go into itself 1 time, and that will go into 3 times. And if you have anything over 1, it just ends up being itself. Okay. All right, let's look at the third example. Now, I know this looks weird because it has a coefficient in the front, but we don't care about the coefficient. The coefficient at number 3 is rational. What we need to do is get rid of the square root of 6. So I'm going to multiply the bottom by the square root of 6 and the top by the square root of 6, which is going to give me 3 times the square root of 36, which is going to be 3 times 6, which is going to be 18. See what I did there? Now the top is going to be 4 times the square root of 6. Now, hopefully by now that you know when you simplify 6, you only get 2 times 3, and nothing's perfect, so we can't simplify that anymore. So we'll have 4 times the square root of 6. But look at the 4 and the 18. Do we have a common factor of 4 and 18? We do. 2. 2 goes into 4 twice. 2 goes into 18, 9. So my final answer would be 2 times the radical of 6 all over 9. Okay. Again, this is called rationalizing the denominator. We're going to make the denominator an integer or a rational number. All right, let's look at this one. Okay. Again, the coefficient out front does not matter. So I'm going to multiply by the radical, which is 30. Multiply by the radical of 30. This is going to be 3 times the radical of 900. Again, you can skip this part, which is going to be 3 times 30, which is going to be 90. All right, now what do you notice about up here? 25 is a perfect square. What's the square root of 25? 5. So now what's 5 times 4? 20. So now we're going to have 20 in front of the 30. So we have 20 in front of the radical of 30. Now, think about 30. Are there any perfect squares that you can pull out of 30? Well, if you can't figure, if you don't remember, look at it this way. We have 10 times 3, and then we have 5 times 2. So you're going to have 2 times 3 times 5. You don't have any perfect squares, so that is simplified as far as it can go. So we're going to bring 20 times the square root of 30 over 90. Now again, the 20 and the 90 are fair game to simplify. 10 goes into 20 twice, and 10 goes into 99 times. So you're going to end up with 2 times the radical of 30 all over 9. Okay. All right, let's do another one. Didn't want to write one down and rub my hand through it. Okay, what if we had 6 times the radical of 7v to the 4th all over the square root of 5v squared? Ooh, let's get you some variables in here. All right, now, because everything's underneath the radical sign, you have to multiply by everything underneath the radical sign to pull it out. So I'm going to end up with the square root of 25, and v squared times v squared is going to be v to the 4th, which is going to give me 5v squared. Again, hint, if you're multiplying it by itself, you just basically pull that out and put it over here. Now the problem is I've got to multiply the top by 5v to the 2nd as well. So we're going to keep our 6 on the outside, and we're going to multiply inside. 7 times 5 is 35. If we have v to the fourth times v to the second, you add the exponents. 4 plus 2 is v to the sixth. All right, now 35, you should know, pretty much figure out that 7 times 5, you can't pull that out. There's not a perfect. But what about v to the sixth? Remember, if we did that out in long term, this would be 7 times expanded form, not long term. It would look like this. Okay, and we have 6 on the outside. And so remember, every pair is perfect. So you pull out a v, you pull out a v, you pull out a v. So I'd end up with 6v to the third times 7 5 is 35. So that's going to go on top. 6v to the third times the square root of 35. All right, now look. This is getting all sorts of stuff in your exponent rules. I have 3v's up here and 5v's down here. If I brought that over in expanded form, that means I have 3v's up top and I have 2v's on the bottom. That v cancels out, that v cancels out. How many am I left with? 1v up top. So this would actually be v, and that would be 1. So my final answer would be 6v times the square root of 35 all over 5. Okay, let's look at another one of those, because that one was a little difficult when we get the letters involved. All right, what if we have, let's do 3 times 8m to the fourth, 3 over the times the square root of 8m to the fourth, over 4 times the square root of 56m to the fourth. Okay. All right, so what I need to do is I need to multiply by my radical to get rid of it. So don't worry about the 4. I'm just going to multiply by 56m to the fourth, which I'm going to jump my shortcut because I don't want to multiply 56 times 56, and m to the 4 times m to the fourth will be m to the 8, excuse me. So what just basically happens is you pull out 56m to the fourth, and this guy comes in front, and you're going to multiply it together. Okay, so then when we have 56 times 4, to come down here to the bottom, we have 224m to the fourth. Okay, that's your denominator. Well, now we've got to multiply the numerator by 56m to the fourth. So now this is where we multiply. We'll be multiplying with radicals. You can either multiply 8 times 56 and get a really big number, or you can break them down individually. I'm going to bring this mess down here, and I'm going to break it down like we did with multiplying. I'm going to have a 3 on the outside, and underneath the radical sign, I'm going to break down 8 as 4 and 2. Okay, so that's 2 and 4. I'm going to break down 56 as 8 times 7, which will be 4 times 2 times 7. So 2 times 4 times 7. Hopefully you see what I'm doing. M to the fourth, that means I have a total. Again, I'm just doing it the long way so you understand what I'm doing. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, and again, we have the 3 out front. Now, pull out any perfect squares that you have. Well, that's a 2, that's a 2. You have a pairs of 2's, which makes 4. Square root of 4 is 2. And then look at all these m's. 1m, 2m, 3m, 4m's. So I'm going to pull out 4m's, and I'm just going to go ahead and write it m to the fourth. Okay. So on the outside, I have 2 times 2 is 4, 5 times 2, 4. Aha! 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. On the outside, oops, I forgot the m to the 4. So 24 m to the fourth on the outside, and then what's left underneath? This lonely 7. So now we're going to bring this up here. 24 m to the fourth times the radical of 7. Okay, now, ooh, look at this, look at this. That cancels this. These completely cancel each other out because you have m to the fourth over m to the fourth, which would just leave you with 24 times the radical of 7 over 224. Now, can I find a common factor of 24 and 224? Let's see, does 224, it's not divisible by 24. Let's see, 224, is it divisible by 8? Yes, it is. So 8 goes into here 3 times, and 8 goes into this 28 times. And then there's not a common factor of 3 and 28. So my final answer would be 3 times the radical of 7 all over 28. Okay, because your m's end up going away. All right, I hope this helped. Hope to see you guys soon.